Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. So today we will be starting a new topic which is speed time graphs. So let's get started. Now, similar to distance time graph, in speed time graphs on x-axis we have time. Okay, it could be in seconds or minutes or hours. However, on the y-axis this time we have speed. Speed could be in meters per second or it could be in kilometers per hour. Okay, now a horizontal graph means that the speed is constant as the time increases. So when we had distance time graph, on that a constant value showed us that the distance was constant, so it was telling us that the object was at rest. However, in this graph, this is telling us that the speed is constant, so the object is moving but at a constant speed. Okay, since the car is traveling at constant speed, the acceleration is zero, because the meaning of the word acceleration is the increase in speed. Okay, acceleration is an increase in speed. If the speed is constant, that means there is no increase in speed and hence there is no acceleration. Okay, so let's say that our speed is constant at 30 meters per second. In the next one, here we have two different graphs. Okay, we have graph of car A and then we have a graph of car B. It says that if the slope gradient of the graph is a straight line as shown, the speed increases at a constant rate. So again, your graph is a straight line, right? That means that the speed is not constant but it is increasing at a constant rate. Okay, so this means that the car travels with constant acceleration, also known as uniform acceleration. So what does this mean that speed increases at a constant rate? This basically means that if let's say that in 10 seconds the speed, sorry, if let's say that in 10 seconds the speed of the car is increasing by 5 meters per second. Okay, so let's say that after 10 seconds the speed of the car was 5 meters per second. After another 10 seconds the speed of the car became 10 meters per second. Let me write that down. So let's say we have speed and we have time. So after 5 seconds the speed became 10 meters per second. After another 5 seconds, that is 10 seconds now, right? So at t equals to 10 seconds the speed is 20. After another 5 seconds, let's say 15 seconds, the speed becomes 30 and so on. So every single time your time is increasing by 5 seconds, but the speed is increasing by 10, and the same goes again. This is what we mean by increasing at a constant rate. Okay, so this is what we call increasing at a constant rate. So whenever your speed is increasing at a constant rate, we say that the acceleration is constant. This is also called uniform acceleration. Now, similar to distance time graph, the gradient of the distance time graph gives you the speed. The gradient of speed time graph gives you acceleration. Okay, so that means car A has a lower gradient. Okay, however, car B has a steeper gradient. So therefore, we can say that the acceleration of car B is more. That car B is accelerating faster than car A. So we can say that car B travels with a greater acceleration since the gradient is steeper. At t equals to 10 seconds, we can also take a look at comparison that at t equals to 10 seconds, car A has the speed 20 meters per second, car B has the speed 50 meters per second. So let's say, so at this particular point, somewhere around here, okay, so this will be my 10 seconds, okay, over here. So let me just quickly mark this again. So 20 meters per second should be somewhere around here. Okay, so this is what we mean by that. That let's say if I'm going to draw a straight line, throughout this, right? And now let's draw a horizontal line. So for car A, at 10 seconds, the speed is going to be 20. But for car B, after 10 seconds, the speed is 50. So this tells us that car B is accelerating faster than car A. The third type of graph will be, sorry, this is speed. This is going to be a curved graph, okay? So you can see that the graph is going something like this. Now, whenever we have a graph which is a curve, that tells you that the acceleration is still increasing, but it is not increasing at a constant rate. Okay. Now the speed is increasing. So that means that acceleration is no longer constant. The speed is increasing randomly, non-uniformly. So maybe after 5 seconds, it increased 10 meters per second. Then after another 5 seconds, maybe it increased by 12 meters per second. After another 5 seconds, it increased by 15 meters per second, and so on. So you can see these values are no longer constant. So this type of situation can be represented by a curved graph. Okay. Now, if we have a graph something like this, okay, this gradient is negative. Why? Right? Because we are going downhill. We are going from left to right, we are going downhill. So that means the gradient is negative. That means your acceleration is also going to be negative, because the gradient of a speed time graph is equivalent to acceleration. If your gradient is negative, the acceleration will also be negative. Negative acceleration is called deceleration. Okay, so there is a word for negative acceleration, and that is deceleration. So if let's say that my acceleration was minus 0.4 meters per second square, this is the unit for acceleration. Okay, so if let's say my acceleration was minus 0.4, I'm going to say that my deceleration is 0.4 meters per second square. So the unit for acceleration is meters per second square. Why is that the case? Because acceleration is equal to speed divided by time. Okay. The unit for speed is meters per second. The unit for time is second. So when this when you have meter per second divided by another second, you take the reciprocal, so this becomes meter per second multiplied by 1 over second, and therefore you get meter divided by s square. That's where you get the unit for acceleration. All right. However, these type of questions are not asked, but just so that you understand why the unit of acceleration is meters per second square. So this is how it is. Okay. All right. Now, so those were just the interpretations of how the graphs look like and what do they tell us. Okay. Now comes the calculations. So similar to distance time graph, the gradient of a speed time graph also represents a physical quantity. In this case, the gradient of speed time graph will give us the acceleration. So let's take a look. If you look over here, we have a point 0 0, and then we have a point 512. Okay, 0 0 and 512. So what I'm going to do is I'm going to work out the gradient. So that would be y2 minus y1 divided by x2 minus x1. So we have 12 minus 0 over 5 minus 0 gives us 2.4. Okay, the gradient is positive because it is going uphill. Okay, therefore the gradient is 2.4, so the acceleration is 2.4 meters per second square. Whatever the value of gradient is, that will be your acceleration. Okay, let's work this out. Now here we have two shapes, right? We have two part journey. So between t is equal to 0 and 10 seconds, the car is moving, or the object is moving at a constant speed of 20 meters per second. okay, because this is a horizontal line. So this is what is represented by that. After that, the car moves from 20 meters per second all the way until it comes at rest, because now the velocity, sorry, the speed becomes zero. So what happens? It has decelerated. How does deceleration takes place? Deceleration basically means the speed is decreasing. Okay. Now, acceleration means increase in speed. Deceleration means decrease in speed. Okay. How does decrease in speed occurs? When you apply the brakes. So when you apply the brake, that is how the car is going to come to rest. So between t is equal to 0 and t equals to 10 seconds, the car travels at constant speed of 20 meters per second. Therefore, acceleration is equal to 0. Now we need to work out the acceleration of this part. Okay, so again, we have taken two coordinates, 10, 20 and 20, 0. We apply the formula to work out the gradient. So we have 0 minus 25 over 20 minus 10. That would be minus 25 upon 10, which is minus 2.5. And it makes sense. Why would we get a negative gradient? Because from left to right, if you look, the graph is going downhill. Okay. All right. So the acceleration is going to be minus 2.5 meters per second square. So when your acceleration is negative, we have another term for that, which is deceleration. So deceleration is going to be 2.5. So remember, when the question asks you to work out the deceleration, you only have to give the magnitude. You only have to give the value, not the sign, because the sign is already included in the word deceleration. When if someone tells you deceleration, it all automatically means that we are talking about negative acceleration. So we don't have to put another negative into our value. Okay. Now, the second type of calculation that we can do from speed time graph is that you can work out the distance that was traveled during the journey. Okay. And that is by calculating the area under the graph. Okay. So what does that mean? If let's say, let's take a look at an example. A speed time graph of a car's journey is shown below. Okay. Now, so this is what the question is. Calculate the acceleration during the first 5 seconds of the journey. Okay, so this is similar to what we did in the previous part. You have to calculate the acceleration between t equals to 0 and t equals to 5. So we take two coordinates, 5, 6 and 0, 0. So we can work out the gradient that will be equal to the acceleration. Okay, so that is part A. In part B, the question says state the acceleration between t equals to 5 and t equals to 10 seconds. So it says state. That means we do not have to do any calculations. What will be the acceleration between t equals to 5 and t equals to 10? From here, you can see that this is constant speed. At constant speed, your acceleration is equal to 0. Okay. Now, if you look at the if you look at part C, calculate the distance traveled by the car in 10 seconds. Okay. All right. Now in 10 seconds, we can see if I draw a straight line all the way down. So we can see that the area under the graph, okay, is actually this shaded part. Okay. Now remember what we said, the distance traveled is equal to area under the graph. So if I look at the shape, I can see that there is a triangle. Okay, and then there is a rectangle. If I can work out the area of this triangle and add it to the area of rectangle, so that would give me the total area of this figure, which will be equal to the distance traveled. Okay, there is another method to do this. Okay. So let's see. All right, first of all, let us do the calculations again. So part A was calculating the acceleration during the first 5 seconds. Okay, so that was 6 minus 0 over 5 minus 0, which is 1.2 meters per second square. The second part was, since the speed is constant at 6 meters per second, the acceleration is 0. Already done. All right. Distance traveled equals area under the graph. So first we work out the area of triangle and then area of rectangle. So distance traveled equals area of triangle plus area of rectangle. Area of triangle is half into base into height, and the area of rectangle is length into width. Now this is your base of the triangle, and then this is your height of the triangle. So the base is 5, the height is 6. As for rectangle, the base or the length, that is going to be 5 units because it is the difference between 10 and 5. The height is going to be 6. Okay, so that's where we get these values. Half into 5 into 6, this cancels, so you get 3, and 3 times 5 is 15. 10 minus 5 is 5. 5 times 6 is 30. You add both of them, you get 45 meters. Okay. Now, for this particular question, this is a bit of a hassle because you need to work out the area of triangle separately and then work out the area of rectangle and then you have to add them, right? Sounds too much work. Okay. What we can do instead is, if you can recognize that this shape is actually a trapezium. Okay, this whole shape is a trapezium. If you remember the formula of area of trapezium, which you should remember, then you can easily work this out. The formula of area of trapezium is half into sum of parallel sides multiplied by the difference between the parallel sides. Okay, in this case, this is your parallel side. So what is the length of this parallel side? That will be 10 minus 5, which is 5. Then the second parallel side is going to be 10. So half into 5 plus 10, and then the difference between the parallel sides is going to be this vertical line, which is 6. Okay, so therefore that would be my method 2, which is trapezium, and I would say that this is recommended because it actually makes your working a lot faster and you can quickly get your answer, which is the same. Okay, so you can see that there are the number of steps are, it might look a bit same, but then there's more working involved here, more calculation, that means more chances of errors. Okay, all right, so that is the lecture part of the video. Okay, in the next video we will start some questions which will be related to speed time graphs. Okay, so I'll see you in the next video then. Take care. Assalamu alaikum.